Okay, I hope to do about a 10-minute video that's actually kind of broken up into two parts so you can jump to the middle if you don't need the beginning part. I'm not turning this into an Edpuzzle because this is purely just for your own understanding. I've got some practice you can do out there, which there should be probably be a link both on Google Classroom and at the bottom of this page if you want some more practice. So just factoring and distribution, which I probably should say distribution and factoring because we typically learn this one first, is something you probably already know from algebra and you will probably need to know for algebra 2. So it's a nice review and it has some, this area model is somewhat related to geometry. So I just thought I'd throw it in to let you learn something a little different while you're at home. So normally when we've got something like this means 2 times the quantity of x plus 3. We know that, oh, that 2 needs to get multiplied times both these things. So we end up with, 2x plus 2 times 3, or 2x plus 6, okay? And that just represents some number. If this was a 10 here, this would be 2 times 13, so the answer would be 26. Or if I plugged in the 10 down here, still the same answer. It's 2 times 10 is 20, it's 26. In this case, we're just writing it in different form and saying, hey, I'll tell you x later. So it's an equivalent form of like this. And sometimes we like to move back and forth. So if I went in the other direction, if I started here and then worked backwards to here, because there's a common 2 in here, I could do what's called factor out the 2, and it would look like that. So this is typically what we learn first, and then kind of working it backwards, we kind of learn this kind of second, what's called factoring, finding the factors. Now, this has, the area model would look like this. It's as if I have a box that is x plus 3 long, some distance plus 3 long, and it's maybe, 2 high. So normally for area, it's length times width, we just multiply these, but in this case, I got to multiply both these. Well, this is kind of set up nicely as like, well, this section of the box is going to be 2x, whatever that is. Once again, if it was 10, that section of the box would be 20, and then this section of the box is just 6. So whatever that number is, that section of the area of the box is 2x units squared, and this is definitely 6x units squared. So I'm like, oh, okay, that's 2x plus 6. So it's just another way to think about distribution. It's really helpful once we get to factoring ones that look like this. So normally the way we do this, most of you have probably learned the FOIL method, which is you multiply the first, the outer, the inner, and the last. This is often called the FOIL method. If I do that, 2x times x, and outer is 2x times 3. That should be a plus in between there. The 5 times the x is my inner, and my 5 times my 3 is my last. And so that's 2x times x is x squared. I get a 6x, I get a 5x, and I get a 15. And we have some like terms there that we can combine. So this is 2x squared plus 11x plus 15. This is traditionally the way we've learned it. And once again, sometimes I might give you this and say, hey, can you work backwards and figure out what this was to start with? And this is where the area model really helps. But let me show you how the original problem would look. So the idea is I have some box. One side of the box, or rectangle, is 2x plus 5. And another section of the box, this height here, is x plus 3. And so I can kind of break it up and say, well, this section of the box has to be these two times each other. So 2x squared, units squared. 5 and x would be 5x units squared. That's going to be 6x units squared. And this is going to be 15. And then notice once again, I have some common terms that I can combine there. So that is going to end up being 2x squared plus 11x plus 15. Okay, and notice our pattern here. These two numbers always multiply to this. These two numbers always multiply to this. And then there's a combination of what we call our inner terms and our outer terms that are always going to add together to get that middle number. So this middle number is always, adding some combination of these things being multiplied together. And that can be very tricky to figure out when you're working it backwards. All right, so let's look at one working backwards. This is the real reason we're doing this. Oh, actually, I'm going to do one more working forward. So working forward, there's a bunch of examples online which look like this. And I'll have that link in there. But the idea is I'm just giving you the model, and you're saying, hey, what is it when I multiply those two? So let me check my notes here. What did I have? Let's say I gave you, I'm going to pick one that's a little more difficult here. I'm going to pick this one. Okay, number 6 here. I'm just going to work that out. So that one right there was, the model was 2x minus 6 going across. That's how long the box is. And negative 6x minus 3 is what that is. So I want to figure out, well, what's the area of this thing? This section of the box is negative 12x squared, just multiplying those two. Negative 6 times negative 6 is going to be a positive 36x. The 2x times the negative 3 is going to be a negative 6x. And the negative 6 times the negative 3, negative times the negative is a positive, so it's an 18. And then if I want to write this more simply, those two combine. So this can be written negative 12x squared, then 36 and the negative 6. So I subtract them and keep the sign of the larger. So that's going to be a 30x, and then plus 18. So what I started with here was negative 6x minus 3 times 2x minus 6, and those are equivalent items. And I could have done the FOIL method, but this area method is really useful, especially when working backwards. So let's talk about that. If I'm working backwards, and there's another screen, and once again, these answers that we just got, we could have plugged right in here, and it would have checked. And if you don't plug in ones that have 1, it'll plug it in for you. I'll let you figure that out. But there is another one that I have open, which looks like this. And this is working backwards. It's like, oh, I'm starting with this, and I'm working backwards to figure out what does this break apart into. So I think I have an example written out. Yeah. The example I have written out is you start with x squared plus 11x. And this is part 2 of it. So if you haven't done the first one and you're not quite sure how to do it, I would stop it now and go back and do the model 1. Okay. So we're on to model 2 now, which is a separate page, which will also have in Google Classroom eventually, probably not today. And then also it'll be at the bottom of the screen. Okay, so the question is, how do I break this down? I want this to be something times something. Obviously, I'm going to have some x's in there, but I don't know what any of the numbers are. So I'm like, well, okay, let's do our area model. We know we're going to have some kind of x and some kind of x, because we know we've eventually got to get an x squared. And then the question is, do I need anything out front of that? And I don't, because this is just like a 1x and a 1x. So I could put my 1's in or not. It's not necessary, but I know that's going to be 1x squared. So that's that section of the model. Okay, and I know down here I've got to get 28. So the question is, well, there's a couple of things that multiply to 28. I can use 1 and 28. I can use 2 and 14. I can use, let's see, what else? 4 and 7. I think they're all my combinations. They're all going to be positive, because this is positive and this is positive. If there was a negative in here, it's a question of maybe they're both negative, or one's positive or one's negative. It varies. But because that's positive and this is positive, they all have to be positive. I don't have to think about that. I'll do another example with negatives in a minute. Okay, so the question is, which of these combinations ends up getting me 11 here? And I might just have to try some. Like if I put 1 and 28, I'm like, well, 1 and 28 don't add up to that. They add to 29. And 2 and 14, that would add up to 16 in the middle. That doesn't work. Oh, 4 and 7. I put 4 and 7 there. 1x times 4 is 4x. 1x times 7 is 7x. Oh, great. Those two add up to 11, which is what I need. And then I've got everything. So I've got x plus 4 from here. And I'm going to change colors so you can see what I'm doing. And I've got x plus 7 from here. And you can put the 1's out front, but they don't do anything. And my worksheet that I've got for you online will fill itself in if you don't put 1's in there. Okay, I think I've got one more. Oh yeah, I've got a really challenging one that I actually had trouble with. And in fact, maybe I'll do one that's not quite as challenging. And let's see. Yeah, let's do this. I see x squared minus 6x plus 8. And so once again, I'm trying to figure out what do I multiply together. So I have something times x plus something or minus something and something. I want this form. So okay, I'm going to have x and x for sure. So in this case, it's x times x. I don't have to think about it. But if this was like 2, one of these would be 2 and one of them would be 1. And I don't know which one. I might have to try some different things. Okay, and we know this has to be 8. So 8, I can do 1 and 8, or I can do 2 and 4. So if I put 1 and 8 there, it'll multiply to 8, but it'll add to 9. And if I do 2 and 4 there, multiply to 8, they add this. Oh, wait a second. There's a negative there. So in this case, I have to think, do one of these have to be positive or negative? If so, which one? Or actually, I'm realizing, well, if I make one of them negative, that's going to make this negative. So I actually have to make both of them negative, because negative times negative still gives me a positive 8. And then negative 4x and a minus 2x adds to the negative 6, which is what I want. Got to have the negative 6. And so I'm going to switch colors again here. I can see that here I got x minus 4. And on the other one, I got x minus 2. Okay. And so x squared minus 6x add together, and then a positive 8 at the end. All right, I'm going to do one more really challenging one that, like I said, I actually got stuck on. Negative 42x squared plus 39x minus 9. And part of the problem was I wasn't paying attention to what this thing has to add up to. Got to add up to 39 here. Okay, so couple of challenges here. Okay, we know we're going to have x's. Here, something that multiplies to negative 42. So one's got to be positive, one's got to be negative. And my choices are 1 and 42, 2 and 21, 3 and 14, and I think they're, 6 and 7. Those are all my choices, and I got them so quick because I've thought about this problem for a while. But sometimes you just have to go through it. You can do what's called a factor tree to figure it out, but sometimes it's just easier to list them all out. And it's important that you notice what all the combinations are, because you can miss one. And this over here, it makes it a little easier. This is either 1 and 9, or it's 3 and 3. And one of them has to be positive and one has to be negative, but I don't know which one, but they've got to multiply to negative. So at this point, this becomes a big puzzle. So I would like you to pause it for a minute and see if you can't figure out, is it 1 and 9, which one's positive, which one's negative, or is it 3 and 3? And in front of the x, is it one of these? And which one is positive and which one is negative? It is a giant puzzle. Good luck. Okay, after much challenging results, I think I got negative 6 and 3. We're going to check it. And 7 and 3. So that definitely gives me my negative 42. That definitely gives me my negative 9. I get negative 21 when I multiply those two, and that's x. And I get a negative 18 when I multiply those two. And the reason it's right is those two actually do, oops, no, this is wrong. Almost. This is a positive. So what do I need to change? These both need to be positive. So if I make this positive, that'll turn positive, and I make that one negative, that'll turn positive. Now we get a positive 39, but we still have the negative 9 for the there and the negative 42 for there. So that whole thing works out to negative 40, works out to negative 6x plus 3 and 7x minus 3. I think that works. Okay, that's plenty. Thanks for watching.